All right, number 1. Which shows 2.6 times 10 to the 4th in standard notation? So, 2.6 times 10 to the 4th. So we have number 1. 2.6 times 10 to the 4th. 2.6. This 4, the positive tells us we're making this number bigger. 4 tells us how many times we're moving it, so we need to move it once, twice, 3 times, and then 4. And fill these in with zeros. So we get 26 with 3 zeros, so 26,001 is C. Moving on to 2. Population of a large U.S. city is 1,703,210. Which of the following best expresses this population? So, we're changing this number to scientific notation. So, 1,703,210. Our base number will be 1.70321. And we need to multiply that by 10 to. Now, the decimal is here, but right now our number, it's there. How many times do we have to move it? 1, 2, 3, 4, 5, 6 times. So 1.70321 times 10 to the 6, 1.7, okay, so time to this 10 to the 6, so it can't be B because that's 10 to the 7th. This number is not even in scientific notation. Not that it's asking, but we want it in scientific notation. And this one has more detail, so the answer to 2 is also C, because it's closest. 3, find the value of negative 6 to the 3rd. So this negative, it's a little confusing because it looks like that negative is attached. And it could be. Either way, we'll actually get the same answer. But since it's not attached, we have to take for granted that it is not. So 6 to the 3rd, so negative 6 times 6 times 6. 6 times 6 is 36 times 6. Well, 36 times 6. 6 times 6 is 36. Carry the 3. 6 times 3 is 18, 19, 20, 21. 216. So negative 216. 3 has to be D. 4. When changing 67,430,000 to scientific notation, how many places is the decimal point moved? Okay, so right now the decimal is here. We need to move it how many times? Our base number in scientific notation would be 6.743. How many times do we have to move it? 1, 2, 3, 4, 5, 6, 7 times. So we have to move it 7 times to get to here, so the answer to 4 is C. 5. Let x be the first factor in expression in scientific notation. What describes this factor? So that's actually just saying that x is the base. And our base number has to be what? Well, it has to be less than 10. So it can't be A or B. So our base number has to be less than 10. But it also has to be what? Greater than or equal to 1. So it has to be less than 10 because there can only be one digit in front of the decimal point. So 5 has to be D. What's the standard notation for a distance of 9.302 times 10 to the 10th miles? Okay. 9.302 times 10 to the 10th. Rewrite it. This exponent is positive, so our base number gets bigger. and bigger by 10 decimal places, so we have to move it 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we have to fill these in with zeros. So we get 9302 with 1, 2, 3, 4, 5, 6, 7 zeros. We got to fill in these commas. 1, 2, 3, comma. 1, 2, 3, comma. 1, 2, 3, comma. So we have 93 billion 20 million. So 9302. 9302. They all have 9302, except for this one. 93 billion 6 has to be C. On to 7. A number between 0 and 1 is written in scientific notation. Which of these describes the exponent? Okay, so a number between 0 and 1. So let's pick a number, 0.7. Okay, this is between 0 and 1. If we have a number line, this is 0, this is 1. That would be right around there, 0.7. How would we write this number in scientific notation? Well, the base number would be 7. We can do 7.0 times 10. Our base would need to get smaller to get to our decimal. So we would need negative exponent, and we would need to move it how many times to get from here to here? We'd need to move it once. So 0.7 in scientific notation would be 7 times 10 to the negative first. So this is our number that's between 0 and 1. And we've written it in scientific notation. Which of these describes the exponent? The exponent would be, so the exponent here is negative 1, and that is a negative integer. So 7 is D.